Here we go with another example of synthetic division, using it to divide one polynomial by another. Here we're going to be dividing 3x cubed minus 4x plus 10 by x minus 1. So to set things up, the number we put out in front is 1. Remember, when you're dividing by x minus some number, that positive number is what goes out in front. And then we put the coefficients of the big dividend polynomial, 3, -4, and 10. But wait a minute, that's not right. Can you see what's wrong with setting it up like that? If I just put 3, -4, 10, the synthetic division is going to think I mean 3x squared minus 4x plus 10. I need to somehow tell it that I'm really dealing with 3x cubed minus 4x plus 10. So I need a 3 for the 3x cubed, and then I need to put a 0 for the missing x squared term to hold its place, and then a -4 for the x term and a 10 for the constant term. So here is the correct setup. 1 out in front, and then 3, 0, -4, and 10 for the coefficients on x to the third, x to the second, x to the first, and x to the 0, the constant term. Now remember how this goes. We add down and multiply, add down and multiply, add down and multiply. So first, there's not anything to really add, just bring down the 3, but multiply 1 times 3 and put the answer here, 3. Add 0 plus 3, that's 3. Multiply 1 times 3, that's 3. Add -4 plus 3, that's -1. Multiply 1 times -1, that's -1. Add 10 plus -1, that's 9. So now we're done with the synthetic division. We can look and see what we got for the quotient and the remainder. So the remainder is this last number here, 9, and the quotient comes from the rest of the numbers in this bottom row. So we started with a degree 3 polynomial. The quotient is going to be degree 2. So the first term is 3x to the 2 power plus 3x to the first power plus -1. 3x squared plus 3x minus 1 is the quotient. And that means we can take the polynomial we started with and write it as the divisor times the quotient plus the remainder. X minus 1 times 3x squared plus 3x minus 1 plus 9. If you multiply that out and simplify it, it does equal 3x cubed minus 4x plus 10. Now, question. If that polynomial is f of x, what is f of 1? What do we get when we evaluate that polynomial when x is 1? Well, one way to answer that question is just to plug in 1 in place of x and do the calculations. 3 times 1 cubed minus 4 times 1 plus 10. You can work that out. Comes out to be 9. But here's another way of doing it. Remember how we took that polynomial, that function, and rewrote it as x minus 1, what we were dividing by, times 3x squared plus 3x minus 1, plus that remainder of 9. Watch what happens if I take that way of writing it and put 1 in place of x. Then f of 1 would be 1 minus 1 times 3 times 1 squared plus 3 times 1 minus 1 plus 9. So what does that evaluate to? Well, 1 minus 1 would be 0. And this second factor, well, who cares what that is? 0 times anything would just be 0. And then that 0 plus this 9 on the end is 9. So now notice how what we ended up with, 9, was the remainder we got earlier when we were dividing. We took this polynomial, we divided by x minus 1, and we got a remainder of 9. And so f of 1 equals 9. So that's an example of the fact that's called the remainder theorem. It says that if you have a polynomial and you divide it by x minus some number k, then the remainder you get is f of k. It's the same as if you plugged in the number k into that original polynomial. So let's look at another example or two to see if we got the hang of what this is saying. So here, f of x is the polynomial function x cubed minus 4x squared plus 9x minus 13. What's f of negative 2? I mean, we could just plug in negative 2 for x and do the calculations, but let's do it using that remainder theorem. The remainder theorem says that f of negative 2 should be the same as the remainder we get when we divide this polynomial by x plus 2. In other words, if we set up the synthetic division with negative 2, the number we were plugging in for x, out in front, whatever we get for the remainder, that'll be our answer. That'll be our f of negative 2. So let's work through it. Bring down the 1. Negative 2 times 1 is negative 2. Negative 4 plus negative 2 is negative 6. Negative 2 times negative 6 is positive 12. 9 plus 12 is 21. Negative 2 times 21 would be negative 42. And then negative 13 plus negative 42 adds up to negative 55. So that's what we got for the remainder, negative 55. The quotient was 1x squared minus 6x plus 21. But we don't really need to know that if all we're interested in is what's f of negative 2. What we do care about is the remainder. That is f of negative 2. So the answer, f of negative 2 is negative 55. And the reason that works is because of the remainder theorem. And the reason the remainder theorem works is because we can take our original polynomial function, write it as x plus 2 times whatever we got for the quotient plus the remainder. Then if we come along and plug in negative 2 for x, negative 2 plus 2 gives us 0. 0 times this other thing is 0, and then that plus the remainder is the remainder, negative 55. Now remember that one time when we got a remainder of 0. The division came out even. The remainder theorem tells us that f of k is the remainder. So if the remainder is 0, that means f of k is 0. That means the division came out even. There was no remainder. And that means that what we were dividing by, x minus k, is a factor of that polynomial. So the factor theorem says that a polynomial has a factor of x minus some number k if and only if that number is a 0 of that polynomial function. Okay, so on with some more examples to try and get all this to really sink in and make sense and get us used to it. So p of x in this example is the polynomial function 7x cubed minus 3x squared plus 5x minus 9. What's p of 1? Well, we can do it two ways. We can just plug in 1 and calculate, or we can use the remainder theorem. We can set up synthetic division with 1 out in front, and then the coefficients 7, negative 3, 5, negative 9. And then whatever we get for the synthetic division remainder, that's the answer. That's p of p of 1. So let's do this. We're plugging in 1, so we're putting 1 out in front. And here we go with the synthetic division. Bring down the first number, 7. Multiply 1 times 7, and write the answer there, 7. Add negative 3 plus 7, that's 4. Multiply 1 times 4, that's 4. Add 5 plus 4, that's 9. Multiply 1 times 9, that's 9. Add negative 9 plus 9, that's 0. So what's p of 1? It's what we got for the remainder. P of 1 equals 0. And because p of 1 equals 0, that means that x minus 1, which is what we were dividing by, is a factor of this polynomial. This polynomial can be factored into x minus 1 times 7x squared plus 4x plus 9. That is what we were dividing by times what we got as the quotient. Since 1 is a 0 of this polynomial, x minus 1 is a factor of the polynomial. Next example. If p of x is, for this example, it's the polynomial function x cubed plus 2x squared plus 9x plus 18, is negative 2 a 0 of p of x? One way to find out is to plug in negative 2 for x and do the calculations. But another way, might be easier, would be to do synthetic division and see if the division comes out even, if we get a remainder of 0. So let's do it that way. We put negative 2 out in front, and we put the coefficients 1, 2, 9, 18, all positive, here. And away we go. Bring down the 1, multiply negative 2 times 1, and I get negative 2. Add 2 plus negative 2, and I get 0. Multiply negative 2 times 0, that's 0. Add 9 plus 0, that's 9. Multiply negative 2 times 9, that's negative 18. Add 18 plus negative 18, that's 0. So what would you say is the answer to this question? Is negative 2 a 0 of that polynomial? Why, yes. Yes, it is. We got a remainder of 0, so p of negative 2 is equal to 0. Negative 2 is a 0 of that polynomial. And x plus 2 is a factor. We can take this polynomial and factor it into x plus 2 times, and then the other factor would be the quotient, x squared plus 9. Okay, you know what? I'm going to save this next example for the next video. So we have plenty of time to look at it and what comes after and put it all together. So see you in the next video.